Okay, so question 1A asks how many people enter the line for the escalator during the time interval 0 to 300 seconds, and t is given in seconds. And it also gives us this piecewise function for the amount of people entering the line. So it's like a rate, and that's given by r of t. So from 0 to 300 seconds, people are going to enter the line for the escalator at this rate, and then after 300 seconds, I guess they just stop. So if we're finding out how many people enter the line for the escalator during this time interval, the total, we can use an accumulation, or that's an accumulation of people. So we can use an integral to find that out. So we're going to set it from 0 to 300 because that's the time interval. And then we're also going to, we're using r of t dt, and that's going to equal the function, this function, the integral of 44 times the quantity of t divided by 100 cubed times the quantity 1 minus t divided by 300 to the 7th power. Oops. And we're taking the integral of that from 0 to 300. And we can't forget the dt, and then we have to just plug it into the calculator. Oop. So you go to math, scroll down to get that integral, and then we set the bounds from 0 to 300. And then we start typing in that function, 44 x divided by 100, and that's going to be cubed times the quantity of 1 minus t, or x in this case, over 300, and that's going to be to the 7th power dx. And if we press enter, we get 270, so that's our answer. 270 people. Okay, so this next question asks, during the time interval 0 to 300, there are always people in line for the escalator. How many people are in line at time t equals 300? To do this, we can start out by first putting the number of people who were initially in line at time t equals 0, which is 20. That's given to us in the problem. And then what we do is add the accumulation of the rate at which people entered, and we subtract the accumulation of the rate that people left. And they said that the people left, or the people exited the line at a constant rate of 0.7 people per second. So we can use an integral to signify that whole value. So we use, we would use r of t, which is the rate at which people entered, and then we would subtract 0.7 because that's the rate at which people exited the line. Then we put dt, and then we would put this into our calculator. So, or r of t though is the function that we put up there, which is, I guess I'll write it out. 44 times the quantity of t over 100 cubed times the quantity of 1 minus t over 300 to the 7th power. Oops. Cross that out. So r of t, this is r of t, and then we subtract 0.7. Should probably group that together. A double thing, okay. And then we're gonna put this into the calculator. So go to math, scroll down to find the integral from 0 to 300 seconds. I'll type in the same thing. parentheses. Let's set 7th power. And we're going to subtract that 0.7. Then dx. Oops. So what we got was 60, but that's just for this integral. That's just the value of that integral. So we still have to add that 20. So 20 plus 60 is 80. So that means that there were 80 people in line for the elevator at time t equals 300.
So question 1c asks for t greater than 300, what is the first time t that there are no people in line for the escalator? And we got from question 1b that 80 people are in line at 300 seconds. And we're also given by the question that 0.7 people leave the line per second, and we're going to use x as a change in time, and we're going to set that equal to 0, and then you solve for x, which is just x equals negative 80 over negative 0.7, which is just 114.286 seconds, which is the change in time. And the question asks for t greater than 300, so it's asking from 300 seconds. So we would have to add 300 seconds to this, and we get 414.286 seconds. And that's the first time that there are no people in line for the escalator for t greater than 300.
I'm Gianpaolo, and I'll be doing part D of question 1. So part D states for 0 less than or equal to t less than or equal to 300, at what time t is the number of people in the line a minimum? To the nearest whole number, find the number of people in line at this time and justify your answer. So when finding minimums, we want to find our critical values, which is where the derivative, our rate, equals 0, and the minimum is going to be where I'm going to use a fun chart for this. Just to help support. Okay, so it's going to be where our derivative goes from negative to positive, because that's where our function goes from decreasing to increasing, creating a minimum point. And so we just want to find our zeros, and our minimum is going to be at one of those zeros. So let's go ahead and find our zeros here. So that's going to be where r of t, our rate, and minus 0.7 to account for the people leaving, equals 0. And we're going to use a calculator to find these zeros. We're going to go ahead and we're going to graph this. It's a little blurry, but I'll zoom it up after I type. So r of t, 44 times x, since it's easier for me, times x over 100. Oops. Cubed times 1 minus x over 300 to the 7th minus 0.7. Enter. Okay, so this is what we're graphing. R of t minus 0.7. So we go to graph. This is what our graph looks like. There's 1 0 at the beginning right here. There's another 0 right here. And we're basically going to calculate for those zeros using one of the functions on this calculator, which is going to be second, and then calculate, and we're going to hit 0. And then this allows us to find the exact value of our zeros. So hit the left bound, we're going to select the left of our 0, then right bound, right of our 0, enter. And then we're going to guess, and then it'll calculate our 0 for us. It says our 0 is where x equals 166.57472. So we're going to use the closed interval test to help support that one of our zeros is a minimum. So usually in the closed interval test, we test for our endpoints, which could be minimums or maximums, and then we test for our zeros. So our endpoints, which are going to be t equals 0, t equals 300, and then the number of people in line. We're going to put these in the table. So at t equals 0, 20 people in the line, t equals 300, there are 80 people in the line. We already have that information. And now we just need to put our zeros in this table. So we have 1, which is 166.57472. We're going to get our second one right now. Second calc 0. And we're going to select our left bound. Do the same thing as we did for our first 0. The exact same thing. Left bound, select, right bound, select, and then guess, and we'll get our 0, and it says our 0 right here is 33.013298. Okay, so now that we have that done, you can stop using calculator for now, and we have to get the number of people in line at those times where it gave us our zeros. So looking at this graph, we actually already know that where t equals 33.013298, that's where the number of people in the line is going to be at a minimum, since it's that's where the derivative goes from negative to positive. But we're just going to get our table values just to confirm that this is our actual minimum. So we already know that from part B how to calculate the total amount of people in the line, and that was given as 20 initial amount of people plus the integral from 0 to t of our rate, which is r of t, subtract 0.7, which is the number of people leaving the line, and then dt. So this is going to give us our total amount of people in the line at a certain time. So we're going to use this equation to solve for our y values here. So let's just go ahead and substitute in 166.57472. You know what? I'm just going to input this in the calculator just to save time. Oh, gosh. Quit. There. Quit. Okay, so we're going to input our integral. So we go to math, then press 9. Get our integral. There we go. And then it's going from 0 to 166.57472. And then we input r of t, 44. We're going to use x as our variable. It's over 100 cubed times 1 minus x over 300 to the 7th, then subtract 0.7 dx. And we don't want to calculate yet. We're going to input 20 plus at the front. Second insert 20 plus. Okay, enter. We got 158.07014 as the number of people in the line. 158.07014. Okay. And then we're going to calculate for our last value, which is going to be our minimum. And that's what the question is asking for. So we're going to input that in our calculator. So we're going to input 20 plus 0 plus the integral of 0 to 33.013298, and then r of t minus 0.7 dt, and put that in our calculator, and then we should get our answer. Okay, so 20 plus math integral 9, 20 plus 0 to 33.013298 of 44. I could have just copied and pasted the previous equation, but I deleted it, so we're just going to type it again. Okay, so we typed that in. Sorry for the blurriness. There it is. Don't know why it's blurry. Okay, then enter. And we get our answer, which is 3.803436931. Now write that down, 3.803. And then it's telling us to round to the nearest whole number, so that's 4. And that's our answer, 4 people in line at t equals 33.013298. And that is our minimum, because if we look at our table, and look at all of the number of people in line, we see that 4 is the smallest amount right here. So there we have it, our minimum.